The first tool that we'll be running today is a 2.5-inch indexable insert drill. Like the boring tools, this drill has the CKB modular tool connection, so assembly is quick and easy through the use of the single tapered set screw. Inside the connection, the CKB floating pin handles the heavy torque load of this cut. This tool will be running at 470 surface feet per minute, rotational speed 720 RPM. With a chip load of 5 thousandths per revolution, our linear feed will be 3.6 inches per minute. Now we'll be running the SW53 boring head. This head is set for balance cutting, which is the most common cutting configuration. The existing hole will be opened up to 2 inches 850 thousandths with this cut, so we'll be taking out 350 thousandths stock on diameter. The tool will be running at 850 surface feet per minute and a feed of 18 inches per minute. So the chip load is 16 thou per rev, but because this tool is balance cutting, it is 2-edge effective and each insert will be taking 8 thou of stock per revolution. The last cut had a load of 135% of the spindle power at that speed. Now we'll run the SW68 boring head in the step cutting configuration and take a much larger cut, but still have the same or smaller spindle load. We've mounted the insert holders in the step cutting configuration, so one cutting edge leads the other by about 16 thousandths. The lead insert was set to 3.2 inches and the shorter trailing insert set to 3.5. So in total, we're taking 650 thousandths out on diameter for this pass. Step cutting is a single edge effective operation, so while we're using the same 850 surface feet per minute, we'll need to cut the feed rate in half. So the 8 thou chip load gives us a linear feed value of 7.4 inches per minute. This cut generated a 128% load on the spindle.